Hello friends, welcome back to my channel, and today we are back with another important question of GATE 2020, which is from the subject of operating system, and the topic is disk scheduler. So you might have seen many questions regarding the disk schedulers using various algorithms like shortest seek time first or first come first serve and so on. So, in the same context, I saw a question which is question number 35 from the set of GATE 2020. And today we are going to see how we solve this so that we get a correct answer and the minimum time possible. Okay. So, the question says consider the following 5 disk access requests of the form request ID, comma, cylinder number, and it's given that the yeah one second yeah it's given that the disk scheduler is particularly at cylinder 100, cylinder number 100, head is at cylinder number 100 initially, and you need to perform the shortest seek time first scheduling. So what do we do in shortest seek time first? We serve the cylinder which is closest to the head, right? We always serve the cylinder which is closest to the head's position. So in that manner, using this logic, we are going to solve this question, and then we are going to answer the following. We are going to check which of the following answers or following options is false. Now this is also very important. Sometimes they ask which is true, sometimes they ask which is false. So you need to read the question carefully. Now let's get into the question. So what I've done is I've already drawn this, you can say, a straight line which serves as a number line or as a line which serves, which basically gives us the idea of where particular positions, where particular requests are and how far they are from the head's position. So as you can see, I've marked all the requests over here in increasing order, right? Like first we have 0, then 30, then 85, then 100 where the head is initially, then 110, 115 and 155. Okay, so now we are going to start solving the question. So now it is shortest seek time first. So first we are going to check which one is closer, which is the first closest request from this current position of head, which is 100. So as you can see that 110 is the one which is the closest, because the difference over here in distance is only 10, whereas over here what is the distance, it is 15, right? So the closest over here is this 110. Therefore, we'll serve R first. R will be served at the first position. So what I'm going to do is I'm going to write the order, serving order over here. So first we serve R. Then, now you also need to check the options, what kind of answer is expected from you. They are not asking about the total um, serving time or anything like that. They are just answering in the order that which one is served before which one, right? So you just need the order of serving the requests. So I mean, this is helpful when you solve the question, because then while finding the answer, you'll have to spend the least amount of time. Imagine if I would have been writing the answer in the form that I moved 10 units um, to serve this request R. Then I keep on counting these units, and at the end of the question I get to know that this was never required. So in that manner you are actually wasting your time, which is very crucial in GATE, right? Okay, so we move on with the question now. Now head is currently at this position, right? It is currently at this position at R. Okay, so now from this position, which is the closest one? You can either move in this direction or you can move in this direction. Obviously, the distance this on the left hand side is larger than on the right hand side, because this weighs only 5 units and this is now what? It is 110 minus 85, which is 25, right? Yeah. So we process this T request next. Again, I change the position of head now. It is over here. Okay. Then now we need to check which one do we need to process the next. Now, if we look in this direction over here and we check the cost over here, it is 155 minus 115, which is 40, right? And similarly, if I check the request over here, 85, so to serve 85, the cost or the distance you can say is 30. So now since it is shortest seek time first, I need to serve the request for which I'll have to travel the shortest. So I'll be traveling in this direction. That means now I'll be serving what? I'll be serving 85. So my new head position over here is Q, and I'll write the next request which is served over here after T is Q. Okay. Now what next? Now I have two requests to be served, S and P. Okay. So S and P. Now again we'll calculate the distance between this and between this. Okay. So over here the distance between 85 and 30 is what? 55, right? So I'll write 55 over here. Similarly, the distance between 155 and 85 is what? 70, right? So now the request again with the shortest distance is S, right? So we'll be serving S first and then we'll be serving P, right? Now we have the order of the requests with us. So now we'll check which is the option which is matching for us. So I'll just write it again over here. The order is R, T, Q, S and P. This is our order, right? Now we'll check. It says which one of the following statements is false. So the first one says T is serviced before P. T is serviced before P. So this is true because T is over here which is serviced before P. So this is true. Then the next one says Q is serviced after S but before T. So this is false. Why? Because see over here Q is serviced after T and before S. So it is just the inverse of what has happened over here, right? So this is false. Now let's check the other options as well. So the next option, C part, says the head reverses its direction of movement between servicing Q and P. So let's see, does that happen? So after between Q and P it says. So after servicing Q, right? After servicing Q, it serviced S. Before servicing Q, where was it? Before servicing Q, it was at T, right? So it was at T, which was 115. This was T, right? So now, before servicing Q, it was at T. So to service Q, it traveled in this direction. Now, Q is serviced. After Q, it serviced S, again moving in the same direction. And after servicing S, it moved in the opposite direction to service its last request. So the direction changed after servicing S. And what does this say? It says the head reverses its direction of movement between servicing Q and P. Between servicing Q and P. So yes, the change of direction has happened between servicing Q and P. Servicing Q was in left direction and servicing P was in right direction. So this is true also. Then R is serviced before P? Yes, R is definitely serviced before P because R was the first one and P was the last one which was served. So clearly we have the answer over here. Our answer is B part. So we are done for this question, right? So I hope I did help you to learn something new in solving these kind of questions. And in case I did, in case you liked the video, please hit the like button below and also press the bell icon so that whenever I upload some new video, some new question, you always get its notification. And if in case you have not subscribed to my channel till now, please subscribe it and please keep supporting my channel like the way you do, like the comments that you provide me and motivate me in providing you with some new content and giving my best. I am really thankful to all of you. Thank you very much.